This question is taken from the ENGAA 2020 Section 2 paper, and it is question 8. The question reads, we have a triangular prism of height 3x, sides of the triangular cross-section are x, density is ρ, gravitational field strength is g, as shown in the diagram here. What is the minimum pressure the prism can exert when it rests on level ground? So the first thing we should think of when we think of pressure is force over area. But what force are we going to be on about when the prism is resting on level ground? Well, this is obviously going to be its weight. So mass times gravity, and the mass is density times volume, which is why they've given us all these parts. So density times cross-sectional area, so half AB sine C, I've used here, times the length, 3x, times g, divided by the area, gives us our pressure. The question wants the minimum pressure. So what could we do in order to get this minimum pressure? So in order to get the minimum pressure, we must have the maximum area to divide by. So minimum pressure implies maximum area. And what's the maximum area that we can get from this triangular prism? Well, it'll be this big face here, which is 3x times x. So that's 3x squared. So if we divide by 3x squared in our expression for the pressure, we get rid of these terms, so 3x and then one of the x's. So then our expression for the minimum pressure boils down to P equals square root of 3 over 4 from here, and then density times g times x. This is the minimum possible pressure it can exert when it rests on level ground.